Chapter 3, Unit 3. We're going to talk about the median. The median is the midpoint of a distribution of scores. So first you would list the scores from smallest to largest, and then the median would be in the middle. For a discrete variable, you would use a whole number or a fraction halfway between whole numbers as your answer for the median. Look at this example below. There are 7 numbers. We put them in order from smallest to biggest. The number in the middle is the median. So 13 would be the median for this data set. Let's talk about how to find the median when you have an odd number of scores. So here's an example. Find the median for the following scores. Step 1, make sure the scores are listed from smallest to largest. In this case, they already are. Count how many scores. In this case, there are 5 scores, so n equals 5. The next step, you're going to divide n in half. So 5 divided by 2 would give you 2.5, and you always drop the decimal for this step. So 2 is what you're looking for. Now you're going to count in 2 places from the left of the group of numbers and put a slash mark. Next, you're going to count in 2 places from the right and place a slash mark. Locate the number between the slash marks. This is the median. In this case, the median is 8. Now let's find a median if we have an even number of scores. So find the median for the following scores. Step 1, make sure they're listed from smallest to largest. Again, they are. Count how many scores you have. In this case, there are 6 scores. That's an even number. The next step is to divide n in half. So 6 divided by 2 would give you 3. You count in 3 places from the left and place a slash. You can also count in 3 places from the right and place the slash, but with an even number, notice that the slash will always be in the same place. Step 6 would be to locate the numbers touching the slash marks, or on either side of them. In this case, 4 and 5 are touching the slash marks. So to find the median, you just average these two numbers together. So halfway between 4 and 5 would give you 4.5. If you wanted to use math to figure it out, you would just say 4 plus 5 divided by 2. It would give you the midpoint. 9 divided by 2 is 4.5. So the median for this data set would be 4.5. Let's talk about interpolation. This is a procedure used for continuous data to find the median when it falls somewhere between the upper and lower real limits of several tied or what we call repeated scores. This is used for continuous data only. So an example, a median time of 3.75 seconds would be reasonable. We would use interpolation. However, a median family size of 3.75 children is not reasonable. We can't have 3.75 children. Let's talk about finding a precise median for continuous data. So let's find the median for these scores. First off, we have to make sure they're in order, which they are. Next step is we count how many scores we have. There's 8. That's an even number of scores. So we take 8 divided in half and we get 4. So we're going to count in 4 from both sides and place our slash mark. For this case, notice that there's a 4 on both sides of the slash, but there's also other 4s in the distribution. This makes this problem a bit more complicated. So let's look at the frequency distribution histogram. So if I made a frequency distribution of this data, this is what it would look like. Notice that there are 4 4s. Remember that 4 goes from the real limits of 3.5 to 4.5. And you have to know that there are 4 4s in this distribution that go from that range from 3.5 to 4.5. So the first thing you have to realize is that the difference between 3.5 and 4.5 is 1 point. That means that we have 4 4s that cover that 1 point. That means that each of the 4s really covers a quarter of the point. And to find that, we just said 1 point divided by 4 of the 4s. How many 4s do we have? 4. So 1 divided by 4. So each one covers a quarter of a point. So let's see what that looks like on a frequency distribution histogram. So this is kind of what it would look like if I drew a quarter. So notice that when we placed our slash mark, that it's after the first 4 in the list of scores. And remember, we just figured out that each 4 holds a place value of 1/4 of a point. So first what we would do is we would start with the lower real limit of 3.5, and then we would add 1/4 of a point because our slash mark is only after the first 4. So if you add 3.5 plus 0.25, that would give you a median of 3.75. This is interpolation. So let's do some learning checks. Again, pause the video before each problem is worked. So what's the median for these scores? Step 1, you should have put the scores in order. You should have found n was 4. You should have divided that by 2 to get 2. You should have counted in 2 scores from each side and placed a slash mark. And then to find the median, you should have found the average of the 2 numbers touching the slash mark. So the average of 6 and 8 would be 7, which would be your answer. Learning check 2. What's the median for the sample presented in the following distribution table? Step 1, list the scores from smallest to largest. So you're going to have to read them off the distribution table. So there are 3 1s, there's 2 2s, 2 3s, and 1 4. You can still list them in order. You're going to find n. N, remember, is the summation of the F column. So add up the F column, there should be 8 scores. Divide n by 2 to get 4. So you're going to count in 4 from both sides and place a slash mark. Step 5, you're going to find the average of the 2 numbers touching the slash marks. Well, there's 2's on both sides, and there's no other 2's in the distribution, so you don't need interpolation. So really, the median is the average of 2 and 2, which is just 2. So there you go. Median is 2. Learning check 3. What is the precise median for the following scores measuring a continuous variable? Here's the scores. Step 1, list them from smallest to largest. Step 2, find n, which is equal to 8. Step 3, divide n by 2 to get 4. Step 4, count in 4 from both sides and place a slash mark. Step 5, find the median. Well, notice that there are 5's on both sides of the slash mark, but there's also another 5 in the distribution, so we have to use interpolation. Okay, so remember that 5 really goes from the real limits of 4.5 to 5.5. Again, that's a distance of 1 point that has to cover all 3 of those 5's. So if I take that 1 point and divide it by all 3 of those 5's, that means that over that 1 point period, each of the 5's covers 0.333 of that point, or a third of that point. So notice that the slash mark in this case is after the second 5. So we need to start with 4.5, which is the lower real limit, and we need to add 0.333 for each of the 5's on the left side of the slash. So that would give us 4.5 as our starting point, plus 0.333 for the first 5, plus 0.333 for the second 5, which is 5.166. Let's round to 2 decimals, and we get a median of 5.17. Let's talk about the median, the mean, and the middle. The mean is the mathematical average of scores. So if you have a score very different from others, typically called an outlier, it's possible to have a mean that is greater than most of the scores. So look at your example on the right there. This population has 6 scores and has a mean of 4, but 5 of the scores are less than the mean. Only 1 score is greater, but it's so much greater that it actually pulls the mean toward it. So in this case, the mean would not be a great use for finding the middle of the distribution. We would actually want to use a median. So the median is not affected by outliers. It simply finds the exact middle of a distribution. Both the mean and median are acceptable methods for measuring central tendency, and they both define the middle of a distribution. They just use different definitions for middle.